Good morning, students. I hope all you are safe by God's grace. Today, we are going to learn a new chapter. Okay, first chapter is completed. A new interesting topic. Chapter 2, Complex Numbers. So far, you might have not heard this, isn't it? Say, before going to the topic, we will first find it out what is that. See, for example, how we will be solving x square minus 4 equal to 0. See, x square is equal to 4. X will be equal to plus or minus root 4. Or x is equal to plus or minus root 4 is 2. Since square is there, we know that two values will be there. One is plus 2 and another one is minus 2. The same way, if it is x square plus 4 equal to 0, we may get x square equal to minus 4, x is equal to plus or minus root of minus 4, x equal to, see, 4 means we may get 2, isn't it? Minus, we don't know to take it out because 2 into 2 is 4. Minus 2 into minus 2 also equal to 4. But one more extra minus we have. That we cannot remove it. Say for this, we are giving, that's an imaginary unit, I. This is an I is imaginary unit. I is imaginary unit. Okay. Now, this I is equal to, from this it is understood, root of minus 1. Okay. Now, we are going to learn the powers of imaginary unit. Powers of imaginary unit. See, I is equal to root minus 1. From this we will find it out. I square, that is root of minus 1 the whole square, isn't it? What we may get it, ma? Root and square will be removed. Our answer is minus 1. I cube, that is, since I square is minus 1, we can write it I square into I. Minus 1 into I, that is minus I. I power 4, that is I power square into I square. I am writing that's minus 1 into minus 1. We may get plus 1. Suppose if it is I power 5, I can write it I power 4 into I. 1 into I, which is equal to I. If it is I power 6, I power 4 into I power 2, I power 4, 1, and I square is minus 1, so again minus 1. See here, this is I minus 1 minus I plus 1. Again I have got I minus 1, the next value may be minus I, and I power 8, that is plus 1. I power 4 into I power 4. So here all for the only 4 values is there. Remaining again the remainder. If the power, for example, if the power is n, that is 4 into the quotient plus k, the remainder takes place 0 less than or equal to k less than 4. Okay, because I power 4 means we will get the value is equal to 1. So only for the remainders. When they are giving a bigger number, we can just write the multiple of 4 plus the remainder. Only for the remainder it is enough to find out the answer. It's no need even find out because we know the remainder may be I square or I cube, I power 4. See, I means I square minus 1 and I cube is minus I power 4 is 1. Is that clear? This is for the positive numbers. Suppose positive powers. The same we will get it for the negative powers also. I power minus 1, that is 1 by I. Since I is there in the denominator, just multiply and divide by I. That is I by I square. See, I by I square, the value is minus 1. So, we may get it minus I. Then I power minus 2. How we can write it? 1 by I square. So we may get 1 by minus 1. That is 1 by minus 1 is minus 1. Next, I power minus 3, that we may get 1 by I cube. We know that I cube, the value is minus I, isn't it? So here also 1 by minus I, multiply by I and I. See, 1 into I, that is I by minus I square. So I by minus I square, the value is minus 1. So I by plus 1. So I power minus 3, we have got the value as I. Same way, if we find out I power minus 4, 1 by I power 4. We know that I power 4, the value is 1. So together, if we are writing value I is there, I equal to I, that's root minus 1 we know. I square equal to 1. I cube is equal to minus I, and I power 4 is equal to 1. Same way, I power minus 1 we got it, minus I power minus 2 is minus 1, I power minus 3 is plus I, and I power 4 is equal to minus 4 is equal to plus 1. Is that clear? So these four values, if you have learned thorough, then the first exercise is easy for us. Okay. See, as I said, I power n, if it is n is equal to 4q plus k, where k is the remainder, 0 less than or equal to k less than 4, isn't it? So I power 4q plus k. See, I power 4q into I power k. That is I power 4 the whole q into I power k. I power 4 is 1, isn't it? 1 power any number is the same into I power k. So we may get only the I power k value. If it is I power 0, we know that is 1. I power 1, I power 2 plus 1. I power 3 minus I, and I power 4 plus 1. See, I power I square, root minus 1 into root minus 1, we make it, that is minus 1, not plus 1, minus 1. So the four values, I minus 1, minus I, plus 1. Using this only we are going to do the sums. Shall we move to the problems? See. Example 2.1, simplify the following. Subdivision 1, I power 7. Subdivision 2, I power 1729. And subdivision 3, I power minus 1924 plus I power 2080. Shall we do it? Two more subdivision is there. First we will complete this 3. I power 7. Simple number. We know that 4 plus 3 is 7. Isn't it? This can be written as I power 4 into I power 3. I power 4. 1 into I power 3. What is that value? Minus I. So we may get together the value is minus I. Subdivision 2, I power 1729. So first we should check, divide and find out the remainder. 1729 divide by 4. 4 fours are 16. 1. We have to take the number 12. 3 fours are 12. Here no remainder. Next number is 9. Here we know that 4 into 2 is 8. The remainder is 1. So here I can write it. I power 1728 into I power 1. So this we know that together the value is equal to 1. 1 into I power 1 is I. So our answer is equal to I. Then subdivision 3. I power minus 1924 plus I power 2018. Shall we divide and find out the remainder? See 1924. 4 fours are 16. 3. Next number is 232. 8 fours are 32. No remainder. The next number is 4. 1 4 is 4. Here the remainder is 0. So here when we write, that is I power minus 1924 into I power 0 plus here 2018. 4. 5 fours are 20. No remainder. 1. 1 is not divisible by 4. So here I have to put 0. The next number is 18. 4 fours are 16. The remainder is 2. Isn't it? So here when I write I power 2016 into I power 2. So together 2018. So here we know that I power 0 the value is 1. Here I square the value is minus 1. So 1 minus 1 is equal to 0. Would you understood? Even if we are getting bigger number, we know to find out the answer. Very simple. See that subdivision 4, summation n equal to 1 to 102 I power n. So n equal to 1 to 102. So I power 1, I power 2, I power 3, 4, 5, 6, 7, 8 till etc. Say I power 97, I power 98, I power 99, I power 100, I power 101, I power 102. I have splitted 4, 4. Because we know first 4 we will get the answer for this. For the remainder only we will be writing the answer, isn't it? That is why I have splitted into 4 terms. So I power 1 I square minus 1, I power 3 that is minus I power 1 is plus 1. See all the terms will get cancelled. I minus 1 plus 1. The same way for I power 5. Till I power 4 we leave it, only I power 1 will be there, that is I. Here I square minus 1. Here I power 3 minus I power 8, 1. So minus I plus I will get cancelled, minus 1 and plus 1 will be getting cancelled. So etc. here. Here 96 will be moved, I power 1. Then I square, I cube, 100 is divisible by 4, isn't it? So the answer is 1. Isn't it clear? So these two we have to split it. 2 terms is left out. So 100 is divisible by 4. So I have written I power 100 into I power 1. 102 I power 100 into I power 2. So all these answers will be 0, 0, 0. I power 100 1. I power 1 is I. Here I square the value is minus 1. So we have got it I minus 1, or even that we can write it as minus 1 plus I. Is that clear? Now subdivision 5 is I into I square into I cube etc. up to I power 40. See here it's in addition, here it's in multiplication. We know that a power m into a power n means we can able to write it as a power m plus n. See? So we can add all the powers, I power 1 plus 2 plus 3 plus etc. plus 40. That is sum of the first 40 natural numbers. We know the formula for sum of first n natural number, that is n into n plus 1 divided by 2. So here the value of n is 40. So I power 40 into 40 plus 1 divided by 2. See this both are divisible by 2. So 1 2 is 2, here 20. That is I power 20 into 41. See 0, 41 into 2 is 82. 820. Now this we have to divide and check it. 820 divisible divided by 4. See 4 2s are 8. The next number is 2. Is not divisible by 4. So I have put 0 and taken the next number, that is 0. Now 4 into 5 is 20. The remainder is 0. So this I power 820 into I power 0. So 1 into 1 equal to 1. Do you all understand this? See, only one problem. This is the example problem. Now we have to move to the exercise problem. See, exercise 2.1. Simplify the following. I power 1947 plus I power 1950. Okay, we can check it. 1947 divided by 4. 4 4s are 16. The remainder 3, 34. 8 4s are 32. 2, 7. Now we know that 6 4s are 24. So the remainder is 3. So here we can write it. 3 means 1944 into I power 3. Now 1950 divide by 4. 4 4s are 16, 35, 8 4s are 32, 30, 7 4s are 28, 2 balance, isn't it? So here even 3 means 3 balance was there. Here we have 3 plus 3 6. In that 4 the balance is 2. Even in your mind calculation you can do it, okay? See, I power 1948 into I power 2. So only I power 3 plus I power 2. I power 3, you know that is minus I. I square minus 1. That's all. Minus I minus 1. Then the second problem is I power 1948 minus I power minus 1869. Okay. This you can do it in two methods. That's one is I power 1948 minus 1 by I power 1869. Or even you can keep as it is and also you can do the problem. But when you are doing, you have to do it with careful. 1948 divide by 4. 16, 34, we know 8 4s are 32, 28. 7 4s are 28. Here the remainder is 0. Now 1869 divided by 4. 4 4s are 16, 2, then 26. 6 4s are 24, 2 balance 29, 7 4s are 28. The remainder is 1. So when we write here, this is I power 1948 into I power 0 minus 1 by, this is I power 1868 into I power 1. Even without writing directly, you can write I power 0 minus 1 by I power 1. Okay. See, I power 0, 1 minus 1 by I. Or even this is 1 minus I power minus 1. I power minus 1, what is the value we have found out? That is minus I. So, we will be getting that is 1 plus I. Is that clear? This is 1 plus I. Or from 1 by I, you multiply by I and I. With that also you can do. Whatever procedure you want, you can do it. Okay. Now the third problem is I power 59 plus 1 by I power 59. This is also simple only. We can divide and check it. 59 divided by 4. 1 4 is 4. 19. 4 4s are 16. The remainder is 3. See here. We may get it. I power 3 plus 1 by I power 3. Because both 59. Now I have written directly. I power 3. The value is minus I plus 1 by minus I. Isn't it? I cube, the value is minus I. Say minus I plus this. There we have a minus. So plus into minus is minus. 1 by I can be written as I power minus 1. Or minus 1 minus I power minus 1. We know that the value is minus I. See here, minus I, minus into minus, plus I. Minus I and plus I will get cancelled. Therefore, our answer is equal to 0. Whichever method you want, you can do it. There is no issue. Okay. Then the next problem is, see here, sigma n equal to 1 to 12 I power n. 12 is divisible by 4, isn't it? We know that when we write sigma, we can split that value 4 plus 4 plus 4, isn't it? 4 plus 4 plus 4 is 12. So when we split it, automatically we will get 0 plus 0 plus 0 because this is in addition. See, if we write I power 1 plus I power 2 plus I power 3 plus I power 4 plus etc. again plus last 4 numbers may be I power 9 plus I power 10 plus I power 11 plus I power 12. Even this also you can write it if you need. So this 4 means we will get 0, isn't it? How? This is I square is minus 1, I cube is minus I and I power 4 is plus 1. Isn't it? So 4, 4, 4. Automatically we will be getting 0 plus 0 plus 0. Even you no need to write this. When we write this 4 terms, automatically we will get the value is equal to 0. Okay. Now the problem number 5 is I square, I cube, etc. up to I power 2000. So this is an addition, this is a multiplication. So we have to do it. This multiplication means it's enough to add the power 1 plus, 2 plus, 3 plus, etc. plus, what is that? 2000. See here, this is sum of the first 2000 natural number, isn't it? We know the formula is n into n plus 1 by 2. So we may get I power 2000 into 2000 plus 1 divided by 2. This is divisible 1000. See, I power 1000 into 2001. We know that I power 1000 is divisible by 4. 1000 is divisible by 4. So I can write it as I power 1000 the whole power 2001. In order to avoid the multiplication, I have written like this because 1000 is divisible by 4. 250 into 4 is 1000, isn't it? So automatically we will get the answer is 1. 1 power 2001, which is equal to 1. Okay, since it is divisible by 4, or else if you want you divide and check it. 2 4s are 8, 20, 5 4s are 20, no remainder, but again we have 1 0 there. Is that clear? Now the last problem is in this exercises sigma n equal to 1 to 10 I power n plus 50. I power n plus 50. So when we give here, you may get I power 51 plus I power, isn't it? 1 plus 50 is 51, 52, 53 till I power 60. Is it not? I power 51 plus I power 52 plus I power 53 plus etc. plus I power 60. Only 10 times. So first we have to check it whether 50 is divisible by 4. No. Isn't it? Shall we check it? 51 when we divide by 4. 1 4 is 4, 21. 11, 2 4s are 8, the remainder is 3. So it is understood here I power 3, here this is I power 4. Again we may get I plus I square plus I cube plus I power 4. Then till 10 terms, 1, 2, 3, 4, 5, 6. Then again I plus I square plus I power 3 plus I power 4. Is it not? So this 4, when it comes automatically, we know that that is our value will be equal to 0. Isn't it? So this is I power 4, not automatically when we get the remainder is 0. Here also this is 0, and here also the remainder will be 0. I power 4 only we will be getting, that is I power 0. I cube, the value is minus I, isn't it? Plus I power 0 is 0. Plus together this 4 terms gives 0 and this 4 terms gives 0. Sorry, I power 0 is 1. So this is 1 minus I. 1 minus I. Either you can write here I power 4 or you can write here as I power 0. Both are same. Okay. I hope you might have understood this. Say, before completing, we will learn what about the numbers. So first we will have that natural number, isn't it? Natural number, that is 1, 2, 3, etc. The next number will be whole number. 0 will also be included in that number. The next will be integer, that we know that plus or minus 1, plus or minus 2, all those things will be there, that is integers. Then the next will be rational and irrational. Rational is the fraction numbers. Rational, Q. The next is rational as well as the next is irrational. Irrational. Altogether this everything gives that real numbers. Altogether this we will get it as real numbers. This real number and that the imaginary, okay, this imaginary and real number together gives the next biggest term, that is complex numbers. So natural number, whole number, the next integers, then rational, irrational, then that together everything real number. Now real number and this imaginary unit together, everything together we will get it as complex number. That's the biggest number. Okay. So regarding their properties, addition, subtraction, multiplication, everything we will be learning in the coming exercises. Okay. Just go through this, and if you have any doubt you can ask me in the interactive session. Okay. Thank you students. See you in the next class. Bye bye.